Welcome candidates to another video of KCP revision. How was your weekend? I hope your weekend was nice and you enjoyed it. But after resting for the weekend, we need to go back to books and get prepared for the exam that is coming. Today, I want us to look at Geometry Part 2B. Part 2B, construction, dropping a perpendicular. That is our subtopic today, dropping a perpendicular. I have prepared some questions to discuss today with you, and they are selected from the 3 KCPE papers, 2009, 2010, and 2012. Just one question from which talks about dropping a perpendicular. So I want us to begin with question 4 of 2009. On the diagram below, construct a perpendicular from point R, to cut PQ or to meet PQ at S. What is the length of RS? So we are going to have that perpendicular here. This diagram I have drawn to scale. So don't you worry about the result because I've drawn to scale. Now, boys and girls, I want to refresh your minds on how to drop a perpendicular from point R. So, and here is point R. That is where you place your sharp point of your pair of compasses. That's where you put your pair of compasses. And then your pencil or my chalk now will go to the line where we are going to meet, the perpendicular line is going to meet. Okay? From the point where we are dropping to the line where we are going, the perpendicular line is going to meet. And so I will draw an arc on that line. And that is our target line. Sorry. Let me widen the pair of compasses to give me better results. Look at how I am drawing that curve carefully. Already the curve is drawn. With the sharp point at R, I am able to draw a curve, a wider curve, to cross the line PQ, at 2 points. And so I have 2 points on line PQ. I have this point on line PQ, and I have that point on line PQ. 2 points. I hope you have seen and you have understood how I have found those 2 points. And so from points, these points I'm going to give them names, X and Y. So this is point X and this is point Y. So I will use these 2 points to make other arcs. My blackboard is limiting. So I am at point Y. I draw a long arc. Point Y, I draw a long arc. At point Y, are we together? Then I transfer my pair of compasses to point X. Point X is here. I draw a shorter arc to cross the first arc. Yes, the 2 arcs are meeting at a certain point here. I will call it point, I'll call it point O. Let me give it a name, O, point O. So that is the point O. Hope you can see that. Then I will join point O and R. Point O will join point R. Now, make sure you try first. If you need to be accurate, you try first. Before you draw a continuous line, you must try first. So try like I'm doing. That was not very accurate. My blackboard might not be very accurate, but you need to be accurate. Construction lines are not short. They must be long, pass through the point and over. Now, that line here has met line PQ at point R. Now, this is our famous point R. This point is point R. That is point R. That is the perpendicular line. Boys and girls, a perpendicular line makes a right angle with the line it meets. It can never be perpendicular without making right angle 90 degrees with the line it makes. So it's meeting line PQ at 90 degrees. This must be 90 degrees, boys and girls. And so we must measure to make sure it's really 90 degrees. Let us confirm. These are a protractor. Isn't it 90 degrees, boys and girls? It is 90 degrees. So this is a perpendicular line. It's perpendicular to PQ. Now, I hope you have understood. As we go on with other perpendicular lines, you will understand even better. But that is 90 degrees. And so we are supposed to measure length length RS. RS is that line. S, not R. Sorry. That is RS. RS is that line. And so we measure line RS. I have given myself a scale to use on my ruler because to avoid shorter, very tiny distances. So RS from that, my 20 is 4. My 20 is 4.5. 4.5, 4.1. Let's see again so that we check it from the point. Yeah, it's 4.2. Now, when you get your measurements 4.2, and I said earlier, I have got 4.2 from here to here. When you get such measurements 4.2, what you need to know is that the answer could be either 4.1 or 4.3. It's 1 plus or 1 minus. So our answer here is choice B. That is our answer. That is our answer. I hope you have understood. Follow me to Kcpe 2010, question 13. Kcpe 2010, question 13. Point S, this point here, and line QR are shown in the space below. They are shown in the space below. Using a pair of compasses, drop a perpendicular from point S to meet line QR at T. Once again, it is similar to that one, but that one was a triangle. But this one is not a triangle. And so we are dropping a perpendicular from point S. And so we make sure we have stretched our pair of compasses to be able to reach the to pass this line QR. So we put it at point S and draw a curve. I have drawn a curve on line QR. I've drawn a curve on line QR. Right? And that curve has made new points here. Let me give this one M and this one N. Right? Those new points are going to help me draw another line. Now I will not use the line, the space below, because it's already having some writings. I'm going to use the space above. So I'll put my sharp point at point M and draw a curve, a long curve above that line. Look at that beautiful curve. Then I go to point N with the same radius or adjustment and draw a shorter curve there. Can we be able to see? The curves have met at a point. The curves have met at a point. And that point, I'll give it point P. That point is point P. Now, point P, now I join it with point S and to the line. Through point S, I make sure that line reaches the other line, the other QR. Alright? Let's see. We try. Our determining factor is point S and P. My ruler is not stable. That's it. That is the line. Now the line has is connecting point S with line QR at point T, and that is point T. We want to prove that it's 90 degrees because we said a perpendicular line must be 90 degrees. We want to prove it. Must make 90 degrees there at point B. Boys and girls, can we read it? It is 90 degrees. It's 90 degrees. So that is correct. So this is a perpendicular line. Right? Now, the question is, what is the length of a line ST? ST is the line that runs from S to T. Line that runs from S to T. Let us measure it in centimeters. Again, I'm using a scale on my ruler. Here on my ruler, 5 centimeters are equivalent to 1 centimeter. That's the scale I'm using. So 15 centimeters are 3 centimeters. I hope you understand. So this could be 3.5 because it's exactly at the middle. 3.5 at the middle between 15 and 20. That is 3.5. So the answer here is B, 3.5. I hope you have followed how I have constructed there. Boys and girls, not always you are supposed to calculate in mathematics. You can also construct and get the right answer. Now, having said that, again follow me to 2012, Kcpe 2012, question number 21. This one is a bit complex, and I'll show you the steps that we're going to use to construct a perpendicular. On the triangle below, PQ are drawn below, construct line RS parallel to QP. RS parallel to QP. I hope that is correct. Parallel to QP. Draw a perpendicular from P to meet line RS at T. It's a bit complex. And so it meets line RS. You must draw a sketch, and I've drawn a sketch here. This is how it will look like. Parallel to QP. So this line is parallel to that line. Yes? So the perpendicular has to come from P to PR to RS at point T. That's how it will look like. So you must always draw a sketch. For every complicated diagram, you need to draw a sketch. So let us begin. One thing I endeavor to find out is to measure the angles. Because for a parallelogram, for a parallel line, we must know the angles, parallelogram. And it's like we will be drawing a parallelogram, as you can see here. A parallelogram. All right? Hope you're understanding that. And so we needed to know this angle here. If we know this angle here, the measure of that angle here, then we'll use it to construct its supplement. So let us measure together angle PQR. Angle PQR is 60 degrees. You can see it's 60 degrees. Angle PQR is 60 degrees. That's the measure of angle PQR. Boys and girls, the supplement of angle 60 is 120. Its supplement, right? Its supplement is 120. And so here we need to construct 120. The interior angle here we need to construct is 120. Look at how we construct 120. We put the pair of compasses at point R. Point R is there, and so we draw a curve on that, almost that way. That curve there, I hope we are following. That's the curve. With the same adjustment, look at how I'm transferring to that end where the curve met the line and draw a curve, a shorter curve there to cross there. Are we able to see that? Now, we join this point. Let's call it point X. We join point X with R, with a long line passing through point X. A long line. Right? I said we try and try. And so we draw a long line. That is the line. That line must be parallel to that line. That line is parallel to that line. If you measure this angle here, it is 120 degrees. Let us confirm, boys and girls. I don't want to feed you with lies. Let us confirm, boys and girls. Is that 120? That is 120 degrees. You can see that. That is 120 degrees. And that's how we construct 120 degrees and 60 degrees, because they are supplementary. Remember, supplementary angles add up to 180 degrees. So that is 120. So the other side is 60 degrees. And this 60 degrees corresponds with this 60 degrees. Let's not go there. We learned that in the last lesson. Now, our main problem is to construct a perpendicular line to meet this line. To meet that line. Draw a perpendicular line from P to meet line RS. We needed an S there, and that is the angle here. Boys and girls, the angle here. The angle here must be equal to this angle here, because it will be a parallelogram. It will be a parallelogram. And so let us look at that angle there, so that we have, let me teach you another way of constructing that angle there. So we extend this line, extend that line, it might not be accurate. Extend that line, and then we measure, we can use a protractor to measure 120 degrees over there. 120 degrees over there. 120 from here. 120 is there. that is 120 degrees. Then we join. So that is S, point S. Are we seeing that? And then now we draw a perpendicular from point P. Point P is here. Then the perpendicular must be on this line, RS. So point P, then RS. Point P and RS. We draw a curve. Boys and girls, I am drawing, look at me, look at me. Can you do as I do? Can you do as I do? Draw, draw, draw. Now I have drawn a curve and I have made some points there. That is point Y, then point Z. Yes, I will use point Y and Z to draw some curves. I don't know where. I can do it from here. At point Y, I draw a curve, a long one. Then I go to point Z. I draw a shorter one to meet the first curve. And that's it. Then I have a new point altogether, and this is the point. This is the point. Point O. That is point O. Now I will join point O and P, boys and girls. I'll join point O and P. Twinkle, twinkle, little star, little stars, little stars, twinkle, twinkle, little star. A great line is drawn. Now I have the new point, that is T, point T, that is point T. This is the point that has disturbed us, but finally we have it. Finally we have it to meet at point P. I am looking for the question. I'm sorry, I did not write the question. The question is, what is the length of line PT? Line PT, this line from here up to there. Before we do that, we must prove that it's perpendicular, 90 degrees. We must prove that it's 90 degrees. Boys and girls, automatically 90 degrees. That's 90 degrees. So we want to know the measure of line PT. PT from P to T. Remember my ruler, I'm using it on scale also. 25, that is, it's 5.4. That's 5.4. 5.4. Let's look at the 5.2, 5.1. Yeah, so that's the answer. 5. In the choices, you've got 5.1, and that would be the right answer, boys and girls. You see how it was from the first step to the last step. You can find other KCP papers and do this practice. You can also find it from your primary mathematics, where you're dropping a perpendicular, and you will be able to do more practice and be ready for KCP. Otherwise, thank you so much, boys and girls. Have a lovely afternoon.